Welcome back, everyone. This lesson is the first lesson in our Unit 9. Now, Unit 9 is going to focus predominantly on volume and then area and arc length of sectors and whatever that means. That means we're basically cutting circles into pieces and finding their areas and the length of their arcs, if you would. But before we get into those specific topics, this lesson is designed for us to go back and remember the area of some basic shapes so that we can use that as a foundation moving forward. So with that said, when you're taking notes on this, please take notes like you normally would. Write down the title and rewrite the objective as an essential question. And then remember, the left-hand side of your notes is for practice and discovery, and the right-hand side is for the actual note-taking. Now, I know you can't ask me through the lesson which side it should go on, so use your discretion about whether it's a practice problem or notes. But with that said, let's go ahead and get started. Our focus today is going to be on not just circumference and area of a circle, but area of any generic shape. So with that said, remember area? Area is an elementary school topic, but it keeps coming back year over year in mathematics because it's an important one. The area of an object is the amount of two-dimensional space within a bounded region. Okay, and the units that we use are square units. So if the length of something is in inches, then the area of something would be in inches squared. Quick review of things: the area of a rectangle, the area of a triangle, and the area of a circle. Remember, the area of a rectangle is base times height. Now, why is that? Because if we take this rectangle and we cut it into a certain amount of units, let's say that we cut it so that it's 4 wide, and let's say that we have it so that it's 3 tall. So something like this. Well, what does the area mean? The area means that we are basically having a certain amount of squares in this object. Okay? So forgive my drawing, it's not perfect, but you can see that because this is 4 units wide and 3 units tall, the area is going to be 4 times 3, which is 12. But what does that mean? It means that there are 12 squares inside this object. Whatever these lengths are in units, it's 12 squares of that size inside the object. So base times height gives us the amount of space in that two-dimensional enclosed object. For a triangle, well, if you remember, the area of a triangle is 1/2 base times height. Now, where does that come from? Well, again, we have the base here and we have the height, and you always have to make sure that the base and the height are what's called perpendicular to each other, that there is a right angle between the base and the height. You can't just say, okay, if this is the base, then another side is the height. This cannot be the height because it doesn't form a right angle with the base. But this dotted line in the middle does form a right angle with the base. It goes from the base to the opposite point of the triangle, and it's perpendicular. So therefore it's the height. Now, where does the idea of half come from? Why don't we just say the area of a triangle is base times height? Well, it comes from the idea of taking a rectangle and drawing a line diagonal across it. And so you can see, just like your mom would make you a sandwich for lunch and they would cut it in half, they would cut it diagonally. Well, when I cut it diagonally like that, I am cutting it in half. So I'm taking the area of a rectangle and I'm cutting it into 2 equal pieces. Well, those 2 equal pieces are triangles, and so the area of a triangle is half of what the area of a rectangle would be with the same base and the same height. Notice that the base and the height here in this rectangle form a right angle, and so the base and the height of the triangle also form a right angle. So that's the area of a triangle. The area of a circle has a funky equation to it. The area of the circle is pi r squared. Now, I can't get into big, long details of why this is true in this format. Normally in class, I would break it apart, and I would actually break a circle into a lot of little, what we call sectors. And the more we cut them into sectors, the more those sectors appear to look like triangles. And so I can develop this idea of the area of a circle that way. If you're interested in this, you can go ahead and Google something like the proof for the area of a circle, and you might find something that's beneficial to you there. But regardless, you're going to want to memorize that formula. Area equals pi r squared. Remember, pi is a number. It's an irrational number because it never ends, but it's a number that represents the relationship between the distance around a circle and the diameter of a circle. We'll get into that a little bit more hopefully later, but remember this formula, area equals pi r squared. Well, how do you remember that? Because area has square units, then the area of a circle will have r squared, square units squared. All right, let's go ahead and take a look at a few practice problems here. If you want to go ahead and give these a shot before you watch the rest of the video, go ahead and pause it. But otherwise, let's go ahead and get started. Number one, what is the area of each of the following objects? So number one, it's a rectangle. The base of this rectangle is 5/3 and the height is 11/2. Oh, Mr. Bunyan, why did you have to put fractions in math? I hate fractions. Because you need to practice fractions, because fractions are a part of math, and if we ignored fractions, then you would never learn fractions. Anyways, let's go on. The area of a rectangle is base times height, and so the base of this rectangle is going to be 5/3 and the height is going to be 11/2. So with that said, when I multiply those, remember when I multiply fractions, I multiply the top with the top and the bottom with the bottom. I was just having this little discussion with my daughter the other day. So 5 times 11 is 55, and 3 times 2 is 6. She's staring at me right now, by the way, while we're going through this video. All right, so that is our answer for number one. We could put it into a mixed fraction or a decimal or something like that, but there's no reason. We can just leave it like this. Now notice there are no units given. Like number 2 and number 3 have units. So here we wouldn't necessarily indicate a specific unit, so we would just say units squared. Remember the units for area are squared. For number 2, we have a circle here. Now notice the different attributes of a circle. We know that the area of a circle is pi r squared. We just went over that. But what does r mean? R means the radius. The radius is the distance from the center of the circle to the edge, if you would, of the circle. We'd say the circumference of the circle, the boundary of the circle. So the distance from the center to the edge. Now notice this 18 inches does not indicate that distance. This 18 inches indicates the distance from one side of the circle to the other side of the circle passing through the center. And if you remember that length that cuts through the center point and goes across the entire circle is called the diameter. So in this case, the diameter is 18 inches, which means the radius going from the center out is exactly half of that. So the radius would be 9 inches. So now I can just plug that into the formula. So we get A equals pi times 9 squared. Remember, we do exponents first, so we're going to do 9 squared, which is 81. So we can say our answer is 81 pi. And our units on this little 2 dashes here means inches, so the units on our area would be inches squared. That is if I'm asking you to leave your answer in terms of pi, so I still want the pi in there. And that's the easiest, simplest way to write it. But when we're talking about applications of mathematics, we don't really leave the pi in there very often, so we would multiply this out. This actually means 81 times pi. And remember, pi is 3.14159 blah, 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 going on forever. But you can use your calculator if you need to. Make sure you don't type in 3.14. Use the pi button on your calculator. That'll give you more digits of pi. But anyways, when I multiply that, 81 times pi, I end up with 254.469 inches squared. For number 3, we can see that we have a triangle here. So the area of a triangle is 1/2 base times height. Remember though that the base and the height always have to be perpendicular to each other, so you have to look for a right angle. Well, the right angle that I see is here. So really, this triangle looks different than the triangle that I gave you before in one sense. It's kind of rotated 90 degrees. So if you can turn your head 90 degrees, so you're looking sideways here, you can see the base and the height a little bit better. The base of this triangle is going to be 15, and the height of this triangle is going to be 10 if you just take it and rotate it 90 degrees. And then simplifying this, 15 times 10 is 150, half of that is 75. The units on this are centimeters, so the units on area would be centimeters squared. That is our answer for the area of a triangle. Let's go ahead and take a look at a little bit more complex of a problem here. Number 4, it says, what is the area of the object below? Now this object is comprised of 3 different pieces. You have a semicircle, you have a rectangle, and you have a triangle. So go ahead and pause the video and do what you think you can on this. Come up with some sort of answer, and then come back and push play and see how you did. So for this, what we call composite figure, we have a semicircle. So we're going to find the area of the semicircle. We're going to find the area of the rectangle. We're going to find the area of the triangle, and then we're going to add all of those areas up. So the first thing I know is that this object here is not a full circle. It's a semicircle. So if the area of a circle is pi r squared, then the area of that half circle or the semicircle would be half of pi r squared. That just makes sense. Now the question is, what is the radius? Well, the only value I have for this circle is this 10. This 10 is the distance from the bottom of the circle to the top of the circle. So that's actually the diameter. The diameter is 10, which implies that the radius is 5. So 5 squared is 25, 1/2 pi times 25, and I'm going to go ahead and put this into decimal form. So I'm going to multiply everything out using my calculator, because I'm going to end up adding that to the results of the other two things. And decimal form is the only way that I can combine the like terms, if you would. So the area of the rectangle now is base times height, and we can see that the base is 13. That's easy enough. What's the height of the rectangle? Well, the height of the rectangle is the 10. So we'd say 10 times 13, or 13 times 10, which is 130. And then this triangle, remember the area of a triangle is 1/2 base times height. Remember, you need to look for a right angle. And so I can see that the base of this triangle is 7, and then the height, there's my right angle, my height goes straight up from that, which is 10 again. So the area of this triangle would be 1/2, 7 times 10, and then that simplifies to 35. To find the area of the whole thing, I'm going to add all 3 things together and then combine those, and so I end up with 204.270. And then the units on this, because it's area, are going to be centimeters squared. Those units are important. Make sure when you're doing your practice problems later on in this assignment that you're including the units, and it's indicated in the problem set. Okay. Let's go ahead and go on to this other idea. So we've talked about area. Area is the amount of space inside of an object. Well, the other part of geometry that you guys are familiar with is perimeter. Perimeter is the distance around an object. It's how many steps you have to take to go around something. It's not the amount of space outside. A lot of students will say, well, area is the amount of space inside and perimeter is the amount of space outside. No, perimeter isn't the amount of space outside. If that was the case, the perimeter would be infinite, because there's a lot of space outside of an object. The perimeter is the distance around an object. So it's like the track on a football field. The distance that you run on the track is the perimeter. Now for circles, circles have a unique word that they use for perimeter. I don't know why they use a different word. Why can't they just say perimeter? Who knows? But the word circumference just means the perimeter of a circle, the distance around a circle. So the circumference is the distance around a circle. So just another quick recap. If the diameter is the distance across the circle, then remember the radius is the distance from the center out, which means that the radius is exactly half of the diameter, or the diameter is 2 times the radius. And I think that just makes sense. Now, the equation for circumference is 2 pi r. Again, it's not an equation that I can really develop in this type of format. I would love to be able to do that with you. But basically, if you were to measure the circumference with a tape measure somehow, and then divide it by the diameter of that same circle, so measure the distance around and divide it by the diameter, you would actually get the number pi pretty accurately. But anyways, the circumference of a circle, or the distance around a circle, has this equation of 2 pi r. So let's go ahead and take a look at an example of this. What is the circumference of a circle with a radius of 9 inches? Well, it's pretty straightforward. If the radius is 9 inches, we can just plug that into our formula. So we'd end up with c equals 2 times pi times 9, which is 18 pi. And the units on this, because we're talking about a distance, we're talking about how far it is from one point to another, would just be the same units as the distance of the radius. So it would be in inches, because those little two lines mean inches. Now, if I wanted to, I can multiply that out and put it in decimal form. So 18 times 3.14159 works out to 56.549 inches. Now, one thing I want to notice about circumference and area, if we were to put them side by side, we notice that circumference is 2 pi r and area is pi r squared. So both the equations have the same exact digits, if you would. They both have a pi, they both have an r, and they both have a 2. The only difference is, where is that 2 located? In circumference, the 2 is just a multiple in front of pi and r. In area, the 2 is the exponent on r. It's the square. And so students will get confused on the 2, which formula is for what. Again, a good way to remember that is area is pi r squared. So if area, let me go back to that equation real fast so we can see it. If area is pi r squared, the units are squared. So if you remember that units are squared, then the area of a circle has to have a square in it. So keep that in mind maybe, and that might help you out. All right, let's go ahead and take a look at a couple other problems. Number 1 and number 2 are just basic problems. Determine the circumference and the area of each circle. So we're just going to plug in the values that we need. So remember, circumference is 2 pi r. In this case, the radius is 7, so we get 2 times pi times 7, or 14 pi, and the units would be inches squared, or sorry, just inches. And then if you multiply it out, you'd end up with 43.982 inches. The area would be pi times r squared, which is pi times 7 squared, or 49 pi. If I multiply that out, I get 153.938 inches squared. For number 2, same thing. Circumference is 2 pi r. But notice that the radius wasn't given. The diameter was given. So if the diameter is 12, the radius is going to be 6. We simplify that, I multiply it out, we get 37.699 centimeters. Plugging into the area formula, you got pi times 6 squared, which is 36 pi, or 113.097 centimeters squared. For number 3 and number 4, these are a little bit more in depth. It says if the area of a circle is 100 meters squared, what is its circumference? So if I'm looking for circumference, that's the question. If I'm looking for circumference, what do I need to know to find circumference? Well, circumference is 2 times pi times r. So I need to know the radius of this object in order to find the circumference. Did it give me the radius? No. It gave me the area of the circle. So the area, how could I work with area? Well, remember, area is pi r squared. There's a radius in the area formula. Well, if I could figure out what r is based on this formula, then I can use that and plug it into the circumference. It says that the area is 100, so I can take the 100 and plug it in to a. So I end up with 100 equals pi times r squared. And now I have just an equation to solve. It's actually a quadratic because you have the r squared there. But anyways, to solve for r directly, we're going to divide by pi on both sides. And we'll end up with 31.831, just typing in 100 divided by pi in your calculator. And then to get r by itself, we're going to square root both sides. Now remember, when we square root, we always get 2 answers. But in this case, because we're talking about the length of an object, how far it is from one point to another, that length can't be negative. So we're going to ignore the negative version of this and just focus on the positive. So the radius is 5.642. And now I can plug that radius into the circumference formula, which is 2 pi r. And so I end up with 2 pi times 5.642. And then if I multiply all that out, I end up with 35.449 meters. For number 4, what is the area of the circle? I spelled who's wrong. What is the area of the circle whose circumference is 150 feet? So this is kind of backwards. Here I'm giving you the circumference and I'm asking for area. Well, again, in order to find area, we need to know the radius. So we're going to take our circumference. Remember, circumference is 2 pi r. We're going to plug in the 150 into c because that's the circumference. And then we're going to solve for r. Well, how do I get r by itself? I get r by itself by dividing by 2 pi. Now, careful when you type this into your calculator. If you type it in incorrectly, or if you have like an old calculator, if you type in 150 divided by just 2 pi, you might get a wrong answer here. So it might be good to do this in pieces. How about you divide 150 by 2 and then divide it by pi? Okay? But ultimately you should get 23.873 as your radius, and then we'll take that and plug it into our area formula. So we get pi times 23.873 squared, and then multiply all that out, we end up with 1,790.493 feet squared. All right, last problem here. In this problem it says a circle is inscribed in a square. Inscribed simply means that the circle hits the square exactly at those 4 points. There's no like overlap where it comes out of the circle, and it's not like it's missing it. It's touching it here, 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 and here. Anyways, the circle is inscribed in a square whose side length is 24 inches. What is the area of the shaded region? Well, the shaded region, you'll notice, is kind of like leftovers. So what we're going to do here is we're going to find the area of the square, we're going to find the area of the circle, and then we're going to subtract those two things, and then we'll end up with the blue region. So the area of the square, remember the square is just a rectangle, so it would be base times height. So it would end up being 24 times 24, which is 576. So the area of the square is 576 inches squared. And then the area of the circle, remember, is pi r squared. Well, what is the radius? Remember, the radius is the distance from the center out. Well, the only number I have is the 24 inches. The 24 inches is the diameter. It's the distance across. So that would imply that the radius is half of that, or 12. So 12 squared is 144, so we got 144 pi. Multiplying that out, you end up with 452.389 inches squared. And so now I know the area of the big object, and I have the area of the whole, if you would. It's a missing piece. I'm going to subtract those two things to find the area of the blue region. So 576 minus 452.389. And then just with your calculator, you end up with 123.611 inches squared, because we're talking about area. All right, that wraps up our lesson on area of basic shapes, area of circles, and the circumference of a circle. Go ahead and do the practice problems below, and I will see you again next time. Remember, if you have any questions, you can log into our next Zoom meeting and ask them there. I will see you around.